Composition of functions, part 1. The diagram below shows a function f illustrated by the mapping diagram from A to B. So we have A are the elements 1, 3, and 5. The function is mapped to B. We don't know what the function is as such, but the elements of B are 4, 6, and 8. So 1 maps to 4, 3 maps to 6, 5 maps to 8. So the function has been applied to 1, 3, and 5 to get 4, 6, and 8. And the function g illustrated by the mapping diagram from B to C. So this time we're starting with the elements in B, which are 4, 6, and 8. And they are getting mapped to the elements in set C, which are 11, 15, and 19. So the function g this time has been applied to the element 4. So 4 maps to 11. And then the function g is applied to 6, and that's mapped to 15. And then the function g is applied to 8, and that's mapped to 19. The red arrows represent the couples of a new function combining f and g. So the red arrows, so we start at 1 and we end up at 11. In the next arrow, we start at 3 and we end up at 15. And in the final arrow, we start at 5 and we end up at 19. So this is the function g after f. So g after f is applied to 1 and we end up with 11 as our output, and so on. It is called the composite function g after f. It is written as g after f, or simply g and f stuck together, which means the same thing. So g with a little circle and f is read g after f. So the couples g after f from the diagram are 1, 11. So 1 maps to 11. 3, 15. So 3 maps to 15. And 5, 19. So 5 maps to 19. We will now consider two functions, f of x equals 2x plus 5 and g of x equals x minus 3, to find the rule for the composite function g after f of x. So notice that the g and the f are stuck together. It doesn't mean that they're multiplied. It means g after f of x. So we find the function f of x and we substitute it into the function g. These functions are illustrated on the right. In f, so in function f, the output is 2x plus 5 when the input is x. So we start off with x for our input. We apply the function f and our output is 2x plus 5. We will now use 2x plus 5 as the input for the function g. So now what was f's output becomes g's input. Since g of x is equal to x minus 3, then g after f of x is equal to g of 2x plus 5. So we're going to replace the x's in function g, so there's only a single x in function g, with 2x plus 5. Now, very important to use brackets here. So we get 2x plus 5 minus 3. So we're replacing x with 2x plus 5. And then 5 minus 3 is 2. So g after f of x is 2x plus 2. We will now consider what happens when the order of the functions is changed. So if we have f after g of x, so what this means is getting g of x and substituting it into the function f. So we start off with f of x minus 3. So we replace any x's in our f function with x minus 3 and make sure you use brackets. So our function of f was 2x plus 5. So we're going to replace that x with a set of brackets and put x minus 3 into the brackets. So replacing x with x minus 3. And then 2 times x is 2x. And 2 times minus 3 is minus 6. And minus 6 plus 5 is minus 1. So f after g of x is equal to 2x minus 1. Since 2x plus 2 is not equal to 2x minus 1, this shows that g after f of x is not equal to f after g of x. In general, if f and g are two functions, then f after g of x is not equal to g after f of x. So now let's have a look at an example. Given that f of x is equal to x plus 3 and g of x is equal to x squared minus 1, find part 1, f after g of 2, part 2, g after f of minus 1, part 3, f after g of x, part 4, g after f of x. Find also the value of x for which f after g of x is equal to g after f of x. Part 1, f after g of 2. F after g, i.e. work out g of 2, then sub that into f, into the function f. So our rough work, or W stands for rough work, g of 2, so we go up to our g of x function, which is x squared minus 1, so we replace that x with a set of brackets and put 2 into the brackets, gives us 2 squared minus 1, which is 3. So g of 2 is 3, and now we're going to substitute that into the function f. So g of 2 we replace with 3, so we're now going to get f of 3. And if we go up to our question, f of x is equal to x plus 3. So replacing that x with a set of brackets and putting 3 into the brackets, so we get 3 plus 3, which gives us 6. So f after g of 2 is 6. Part 2, g after f of minus 1. G after f, i.e. work out f of minus 1 and then sub it into g. So our rough work, we're going to work out f of minus 1. So we go up again to our question. Our function f of x is x plus 3. We replace the x with a set of brackets and put minus 1 into the brackets. And minus 1 plus 3 is 2. So f of minus 1 is 2. And we're now going to substitute that into the function g of x. So g of 2. So we go up to our function g of x, so x squared minus 1. Replace the x with a set of brackets and put 2 into the brackets. So we get 2 squared minus 1, which gives us 3. So g after f of minus 1 is 3. Part 3, f after g of x. So f after g, i.e. work out g of x, then sub it into f, into the function f. So there's no rough work to do here as such. I'm just writing out what the function is. So g of x is equal to x squared minus 2. So we're going to substitute x squared minus 2 into the function f. So we're going to replace that x with a set of brackets and put x squared minus 1 into the brackets. So we're going to work at f of x squared minus 1. So we've got x squared minus 1 in the brackets, and then we're going to add on 3, which gives us x squared plus 2. So f after g of x is x squared plus 2. Part 4, we're going to work out g after f of x. So g after f, i.e. work out f of x, then sub it into g. So there's no rough work to do here as such. We're just going to write down the function. So f of x is equal to x plus 3. And then we're going to substitute that into the function g. So we're going to go back to g of x, which is x squared minus 1. We're going to replace that x with a set of brackets, and we're going to put x plus 3 into the brackets. So g of x plus 3, we're going to have x plus 3 to be squared plus 1, which is going to be x plus 3 times x plus 3 minus 1. Sorry, minus 1, not plus 1. I'm going to do rough work over here at the side just to save space. So we've x plus 3 times x plus 3 will give us x squared plus 6x plus 9. So that's where that came from. And then we're just going to bring down the minus 1. Don't forget your minus 1. And then simplifying, we get x squared plus 6x plus 8. So g after f of x is x squared plus 6x plus 8. Next, we want to find also the value of x for which f after g of x and g after f of x are equal. So f after g of x is equal to x squared plus 2. We work that out in part 3. G after f of x is equal to x squared plus 6x plus 8. We work that out in part 4. So we literally just let them equal each other, let them equate, and solve for x. So we're going to do letters to the left, numbers to the right. So we end up with x squared minus 6x equals 8 minus 2. The x squareds will cancel, so we have minus 6x equals 6. Solving for x, we get x is equal to minus 1. So the value of x for which these two functions equate, these two composite functions, is minus 1.